COMET is an experimental system developed at Columbia University that generates interactive multimedia instructions for equipment maintenance and repair. COMET combines research in learning, in natural language generation, and in knowledge-based graphics. The form and content of all text and graphics is created interactively. Thus, instructions can be customized on the fly for the individual user or situation. In our work, we have concentrated on coordinating multiple media. This makes it possible for the text and graphics that COMET generates to work together to communicate information effectively. We are using a radio modeled after the Army ANPRC 119 communications radio as our experimental domain. COMET has hierarchical models of the radio and its components and of a number of actions that can be performed in maintaining and repairing the radio. These models are encoded using ISI's Loom knowledge representation system. An additional graphics model, key to the Loom representations, allows 3D shaded graphics, such as that shown here, to be created efficiently. COMET also has an underlying expert system that enables it to diagnose user-specified problems and to suggest tests and repair procedures. Let's look at COMET's architecture. On receiving a request for an explanation, the content planner uses text plans or schemas to determine which information from the underlying knowledge sources should be included in the explanation. The content planner produces the full content for the explanation, which is represented as a hierarchy of logical forms. Each logical form specifies what information is to be communicated, but doesn't specify how the information is to be communicated. The logical forms are passed to the media coordinator. The media coordinator determines which pieces of information are to be communicated in text and which in graphics. It refines the logical forms by adding directives that specify these assignments. Each annotated logical form is passed to a set of media generators. COMET currently has a text generator and a graphics generator. Each generator creates material in its own medium to express information that the media coordinator has assigned to it. The resulting text and graphics are passed to the media layout component, which formats the final presentation, determining where on the display information is to be presented. Real-time rendering and typesetting components then produce the finished display. Each of COMET's major components runs in parallel in its own process on 5 Sun and HP machines. Text is displayed using the X11 Windows system, while 3D shaded graphics are displayed using HP's Starbase graphics package. Interaction with COMET is initiated through a menu. A user can either invoke the expert system to diagnose a problem or request an explanation for how to carry out a specific repair or test procedure. We'll start off by specifying a problem. COMET displays a list of possible symptoms that it knows about. This time we have a problem with loss of memory. When we turn on the radio, the transmission frequency that we stored previously is not displayed. The first step is to install a new holding battery, whose job it is to maintain the stored frequency. The text is generated by the explanation component. Graphics are not shown for this first step since it is a high-level abstract step containing many complex sub-actions. The user can ask for a detailed explanation of the step by pressing the More button. Since additional detail has been requested, COMET generates a sequence of displays containing text and pictures. In this case, there are 7 displays, one for each step in the installation procedure. The user can skip around between steps, go through them one by one, or can review previous steps if desired. In this first step, the user is instructed to stand the radio on its top side. None of what you see is canned. All text and graphics are designed and generated after the user requests to see the display. The user must now remove the battery cover plate, loosening the screws and pulling the plate off the radio. Note that COMET is capable of producing complex sentences. Here it uses a conjunction. In designing the pictures, COMET decides to use an arrow, seen in the right-hand picture, to show how to remove the cover plate. The user now removes the old holding battery. Next, the user is asked to clean the compartment if it is dirty, and then to check the battery's polarity. The new battery is placed in the compartment. Finally, the user is instructed to replace the cover plate by aligning it with the compartment and tightening the screws. Now we'll go on to step 2 in the troubleshooting procedure. In this step, we are requested to load channel 1's transmission frequency. We'll ask for more detail by pressing More. The first 3 steps in loading the transmission frequency involve adjusting various knobs on the radio's front panel. The media coordinator has specified that both text and graphics are to be used to tell the user to turn the channel knob to position 1. Here we see how the text and graphics generators use different resources to achieve the same communicative goal. For example, graphics uses an arrow to illustrate the action of turning. The arrow's tip indicates the point to which the knob is to be turned. Text selects the verb to set, since the knob has discrete settings. Here, the lexical chooser uses semantic information in the underlying knowledge to influence its choice of verb. The user is next requested to set 2 other knobs. Finally, the user is asked to enter the frequency. This task requires a sequence of actions which are represented by a single complex logical form. Many of these actions involve pushing buttons, as shown in the pictures. The media coordinator decides to express much of the information in text only. For example, the overview, enter the frequency, is expressed only in text. The next sentence contains several pieces of information that are communicated in text alone. The causal relation between pressing the frequency button and the display showing an arbitrary number is expressed only in text. Note how COMET can use embedded sentences, as in, this will cause the display to show an arbitrary number. As well, the fact that the number is an arbitrary one, rather than the specific number shown in the picture, is communicated clearly in text by using the word arbitrary. Here, text is used to express concepts that would be difficult to encode graphically without requiring that the user learn new graphical conventions. In contrast, COMET expresses other information only in graphics. For example, the picture tells us where the button is located, its size, and its shape, while the text does not. These are all pieces of information that the media coordinator has specified should be communicated by graphics rather than by text. At this point, we'll return from this explanation to COMET's top level. Now let's look at a few other examples of displays from explanations produced by COMET. This display helps explain how to remove the radio's primary battery. Here, COMET's graphics generator uses a combination of techniques to indicate that the latches are to be unsnapped. Arrows specify the direction of unsnapping. In addition, the latches are shown both before and after they are unsnapped, with the before version shown as a transparent ghost image. The text generator is able to select words based on the previous discourse. Since the system has previously instructed the user to remove the primary battery, it later says, reinstall the primary battery, return the primary battery to the radio, instead of just using the word install. You have seen several examples of integrated multimedia explanations generated interactively by Columbia University's COMET system. All text and graphics have been created on the fly by COMET's text and graphics generators. Fine-grained coordination between these generators was accomplished through the use of a common content description. COMET's media coordinator annotated the content description to indicate which generators were supposed to express which information. We're currently extending COMET in a variety of ways. For example, we're making it possible for the media coordinator to negotiate with the generators and for the generators to communicate with each other. This will allow even tighter coordination between text and graphics. Systems based on the techniques that we're developing for COMET will someday make it possible for multimedia technical documentation to be routinely created on the fly, customized for the individual user and situation.